Okay, guys, now we're going to talk about springs, right, and Hooke's law. So in this case, as you can see, this is a spring with no load attached to it. So we call this the original length, or L node. And this one has got a force or a load that is attached to it, so it extends. And this one, we increase the force, so it extends even more. So now to calculate the extension is equal to the total new length, for this example is L2, minus the original length, which is L node for this case. Now for this force, you could do it again for the new length, which is L1 minus L node, and so on. Okay, why are we doing this? To get a relationship between force and extension. So Hooke's law states that force and extension are directly proportional until the limit of proportionality. Okay, this is given in the law of force is equal to K multiplied by delta L, where F is the force, K is the spring constant, and delta L is the change or the extension. Okay, now what is a spring constant? It tells you how much or how stiff is a spring is, or how hard is it to extend this spring. All right, so we draw a relationship between force and extension, where the line is, for example, at this stage, this is where the force and extension are directly proportional to each other. So at any point in the straight line, you can get the gradient, which is going to be the force over the extension. So this is going to give you the spring constant K. So as you can see, this is the loading graph. So at this point, this is the limit of proportionality. After that point, if you increase the load, the spring is not gonna act elastically, it's gonna plastically deform. And when you remove the force, it's gonna go back to a plastic deformation when there is a delta L that actually happened to the spring. Okay, so a quick hack, it always bends toward the extension in any case, so they could give you the force and extension or the extension and the force. So in this case, this is delta L over F, so this is 1 over K. So keep that in mind, okay? Excellent. Now we move to this table they always get. To understand this table, sometimes they don't tell you what is the original length. So you have to understand that the original length is where the force was 0 before extension even started. So you could get that extension, you could get the original length from knowing that fact. You also need to know how to convert from grams to Newton. So the first thing is you divide by 1,000 to convert it to kilograms. So that's going to give you 0.1 kilogram. And then you multiply it by the gravity. In this case, it was 10. So 10 Newton per kilogram. So the kilogram cancels out with the kilogram times 10 gives you 1 Newton, and so on. Okay, keep that in mind. These are the basic ideas of force and extension. This one is out of scope, so don't study this and solve more questions to understand. Thank you.